Welcome all to week 3 of the Learning Analytics and Knowledge Open Online course. We're very privileged today to have Ryan Baker join us for a talk. Ryan has been one of the visionaries behind the development of the educational data mining community, now the International Educational Data Mining Society. He is their current president, and he's been very active in publication, nurturing the community, moving it forward, and certainly been very active in interacting with us in the learning analytics field as well. There's a significant amount of overlap between these two communities, but there are some distinct attributes of each as well. So we're pleased to hear literally from the source, from the educational data mining field, how he sees the field and where he sees the field going. Ryan, a pleasure. Over to you.
Well, thank you very much for your kind words, George. And everything great you said about me, and that was very kind of you. I would say the same about you and your leadership in the learning analytics community. It's great to be here. Thank you all for being here today. If you have, so as was mentioned, George mentioned that last year we had some audio problems. I've turned off the automatic volume adjustment, and I've turned off the echo control because I got headphones on. But if anyone stops hearing me, please send a message and we'll try to figure out what happened. So let me talk now about some thoughts on educational data mining. And see if I can go to the next slide successfully. There we go. So EDM is a growing research area with important overlaps with learning analytics. The two research communities have so far grown largely in parallel, which I think is actually a great thing because it's allowed us to articulate two visions for what we're going to do with big data in 21st century education. EDM, the definition we use over in EDM land is the area of scientific inquiry centered around the development of methods for exploring the unique kinds of data that come from educational settings and using those methods to better understand students in the settings they learn in. And I think learning analytics would share this value. One particular thing of note is that EDM is very focused on methods that draw from data mining, taking data mining methods and adapting those methods to the unique aspects of educational data. Art Gracer, academics love to cite authority, and I don't know any authority better than Art Gracer, the editor of the Journal of Ed Psych, who said that EDM is escalating the speed of research on many problems in education. Because not only can you look at unique learning trajectories of individuals, but you can make more and more sophisticated models. So the EDM conference started in 2008, and before that there were workshops back to 2005. We founded a journal in 2009, which is free online. I should mention, our conference proceedings are free online to anybody. Our journal past issues are free online to anybody. And I would encourage everybody here to go and take a look and see what you think is interesting. And a couple of years ago, we founded the International Educational Data Mining Society, which somehow I got elected president of. And it's been great to see the learning analytics community building its own institutions. First the conference, and now the journal and Society for Learning Analytics Research. I think it's fantastic that we have these two organizations working hard together to kind of build the field forward. With the emergence of the EDM Society and SOLAR, there's an opportunity to articulate two visions of the future of how educational data will be explored. And the two visions have considerable similarities, but they have differences that matter too. I really think we need to cooperate, collaborate, and share, and should also attempt to articulate differences in values and methods in a spirit of friendly competition. Let's find out what really works best. Some key similarities, and this is drawn in part from a short paper that George and I wrote last year, include data-intensive approaches to studying learning and learners, with the goal of improving education and basic research in education, and driving planning, decision-making, and interventions, whether they're delivered by a teacher or some other human, or in an automated fashion. Some of the key differences, one thing that I like to think about it is the difference between LAC, which often tries to leverage human judgment with automated discovery, versus EDM, which tries to do automated discovery that leverages human judgment. And this is more than just a clever reversal of terms. I actually look at it as LAC is really, most of the papers really have the goal of trying to improve a human ability to make decisions leveraging data mining and automated discovery methods to inform people better. Whereas EDM very much has the goal of promoting automated discovery, but human judgment often gets brought into, for example, in creating that we then try to fit a model to predict. Another interesting difference is that learning analytics, to a relatively greater degree, there's a stronger emphasis on understanding systems as wholes in their full complexity, a more holistic or dialectical approach, whereas EDM has a stronger emphasis on reducing phenomena to components and trying to analyze individual components and the relationships between them. And this is the kind of split that you'll see through, I think, the educational literature going back at least 100 years, and really, if you want to go back far enough, arguably to some of the debates and instructional methods you even saw in ancient Greece. So it's a long-standing difference in how we look at things, and I think both approaches are really valuable. And I'm having a brief technical moment where my mouse isn't working. One sec. Here we go. Sorry about that. You know, as a quick aside, I did a PhD in human-computer interaction, and I don't think computers have ever forgiven me for that. Didn't buy it. So learning analytics, another key difference is that there's focus, although it's a partial thing, on forming and empowering instructors and learners. And I think one really classic example of that is the Purdue Signals project, which you guys are going to be hearing about at some point, if you haven't already, which very much tried to provide information to instructors that could be used by the instructors to provide messages to students. Whereas educational data mining research typically has a greater focus on automated adaptation, e.g. when the computer adapts with no human in the loop. Another difference I think is really important is that learning analytics historically has had a greater focus on addressing the needs of multiple stakeholders with information drawn from the data, whereas EDM has had a greater focus on issues of model generalizability across settings and populations. So some types of EDM method, and this comes originally from a summary that Kalina Yosef, the current editor of the Journal of Educational Data Mining, and I wrote together 3 years ago. But George and I have been working on kind of updating some of this recently. By the way, George, I just had to use that picture because I thought it was an awesome picture. And some of the methods you'll see are broadly prediction, structure discovery, relationship mining, the distillation of data for human judgment, and discovery of models. And let me say a few words about what each of those are. So prediction is when we have some construct that we want to predict, and we actually have labels of it in the data. So that's where the kind of EDM using data mining that leverages human judgment comes in. So for example, we might have a case where human observers take field notes on kids' emotion as they use educational software, and then we try to build a model that can predict that. Or alternatively, you might see a case where we want to predict what's going to lead to a student dropping out or failing to succeed in the course, and there's been a lot of great work along those lines. Latent knowledge estimation is a particularly important special case of that in EDM, where we're trying to estimate the knowledge that's in the learner's head from their behaviors within a learning system or situation. Structure discovery is when we don't give the model an indicator of what we're looking for in advance, and we try to find the structure in the data implicitly just from the data itself. And network analysis, like social network analysis, is a particularly key application of this in learning analytics. Domain structure discovery is a particularly key EDM application where we're trying to find from student patterns of success and failure on different items, which items actually group together into concepts or skills. Relationship mining is where we have a lot of variables. We try to find the relationship between them. And distillation of data for human judgment, kind of self-explanatory. Discovery of models is when we have a model of some phenomenon, and we link that model up to other models or other variables, other data, to try to conduct basic discovery on learners and learning. And discovery of models has been a particularly prominent type of paper in educational data mining over the last few years. And many of these overlap with traditional data mining methods. The prediction models like classification or regressors are classical data mining methods, but cases like latent knowledge estimation, domain structure discovery, and discovery of models are particularly prominent in EDM. So, in illustrating how these methods can be useful, I'd like to share some thoughts on my vision of how EDM can contribute to education. And it may be interesting afterwards to discuss how this vision is similar to, and maybe different from, various perspectives on how learning analytics can and should contribute. And this is called Educational Data Mining, Predict the Future, Change the Future. So, increasingly, and as I assume most of you or all of you already know, an increasing amount of student learning is occurring within the context of educational software. Clearly, learning analytics and EDM is done on data aside from this kind of data as well, but this is a particularly prominent source. So you have systems like, in the top left corner, the INKITs, formerly called science assessments, where students have scientific simulations that they can experiment with, change the variables on, and look at the data that comes out to interpret it. And research has been done to try to model student inquiry strategies and the students' latent knowledge of how to inquire from this, and also students' engage and disengage behaviors. In the bottom left, you'll see Zombie Division, which is a game used in some elementary schools in the United Kingdom, where skeletons have numbers on their chests, and the player has like weapons, like they have a 2 sword and a 5 gauntlet. And if they see a skeleton that's divisible by 2, they can kill it with the 2 sword. But sometimes the player will run away when they don't know what to do, or when they can't kill the skeleton. For example, they get a 7 skeleton and they only have a 2, 3, and 5. On the top center, you'll see virtual performance assessments coming out of Harvard, where students run around a virtual world, picking up objects, taking them into the lab and running experiments, talking to non-player characters, all in the service of trying to solve some inquiry mystery. Bottom center, you'll see Reasoning Mind, which is a math tutor used by about 70,000 kids in Texas and other parts of the U.S. South every day of the week. And in the far right, you'll see Assessments, which is another math tutor used for middle school math by about 40,000 kids a year in the northeastern United States. Assessments assesses while it assists, so it supports and scaffolds students in learning math, while at the same time assessing their student knowledge, of the math, well enough that it can predict student scores on the state standardized exam about as well as the state standardized exam can predict itself. So in systems like these and many others, we're generating these enormous quantities of educational data. And that all gets expressed in student log data that tells you everything the student did. Typically the student's action, the timing on when it occurred, and what it means semantically. For example, what skills are involved. And just to give a plug to some of my friends, a lot of this data is now stored in a public repository called the Pittsburgh Science and Learning Center Data Shop, run by Ken Kadinger and its technical director, John Stamper. And the PSLC Data Shop has about 200,000 student hours of data right now that anybody in the world, anybody in this room, after I'm done talking, take 15 minutes, make an account, download some data, and you can play with it. And that's been a really nice resource for making it possible for researchers who aren't directly linked, for example, to one of these educational software systems to do some really cool analyses. We can predict a lot of things from that data. For example, there's been about 2 decades of research now, kind of preceding learning analytics and EDM, but really, I think, being the first form of it, 2 decades now to infer student knowledge that changes during learning. There's also been a lot of work in the last decade on disengaged behaviors. So for example, modeling and gaming a system. When a student, instead of trying to figure out what the answer is and typing it in, tries 1, 2, 3, 4, 5, so on to 37. And you might say the students are learning something from doing that, but they're probably not learning much math. Another example would be off-task behavior. We've now had a couple different papers where researchers were able to infer whether a paused student was off-task, maybe talking to another kid about One Direction or Spider-Man, or was asking the teacher for help just from what goes before and after the pause. Another example would be carelessness, models that can infer the probability that a student errors not due to not knowing the skill, but is due to being careless. And my personal favorite, WTF behavior, which stands for without thinking fastidiously, which is when a student does something in the learning system that is just completely incomprehensible. So an example might be in a virtual environment like the virtual performance assessments or Crystal Island. This was originally reported in the context of Crystal Island, which is a very similar designed environment. Students, instead of trying to figure out why everyone on the island was dying, would instead go to the tree, get a banana off the tree, take it to the toilet, flush it down the toilet, go back, get another banana, and spend a half hour flushing bananas down the toilet. People will also be able to infer metacognition, for example, self-efficacy, uncertainty, and confidence. Unscaffolded self-explanation. That's where a student chooses, when they get some feedback from the system saying that they were wrong and the system has an explanation why they're wrong, do students actually stop and self-explain it? And help avoidance. Do some students systematically avoid asking for help even when they really need it? In the last couple of years, we've also gotten better and better at inferring, just from log files of student interaction within educational software, a range of affective states, including boredom, frustration, confusion, and engaged concentration, which is the affective state associated with Csikszentmihalyi's construct of flow. Kind of time drops away, you get really engrossed in activity. And despite thinking that there's pretty limited information in log files, the latest models are almost half as good as human beings are. That is to say, they agree with human beings almost half as well as human beings agree with each other. So that's great. And it's cool that we can model all these things, but in some ways it's just the tip of the iceberg. And here's a picture of an iceberg. Because it's nice to know where a student is now, what their emotion is now, what their knowledge is now, but it's even better to know where they're going. So for example, is the student, even if they're succeeding now, are they going to fail the course eventually? Or perhaps are they going to be not prepared for the next course? Maybe they'll get through this course, they'll get through Computer Science 1, but when they get to Computer Science 2, boy, they're lost. Or maybe they'll get through all their courses, but then they won't be prepared for their career. Maybe they'll be intellectually prepared, but they will have motivational factors that will cause them not to go on. It's a well-known phenomenon that many students from traditionally underrepresented and disadvantaged communities will often say that a career in science or math is not for me. It's not for people like me. And it's only kind of if you can get past all these things that you can get to career success. Well, I'm sorry to hear you guys are having sound problems. If it persists, let me know and we'll try something. So, all right. So I'm seeing a whole bunch of people saying, "Okay, I'm told to keep going, so I will keep going." So recent work has been able to predict things like which students are prepared for future learning. So, for example, let's say we have students that look the same through the first topic in the learning software, but then they diverge in the second topic. Can we predict from their learning in the first topic which one of these they're going to be? And it turns out we actually can. Some work in my group, we've been able, by using a combination of metacognitive behaviors and also dynamics of how learning occurs over time, to get some fairly decent predictions of which students are going to be prepared to learn the next topic. Even, let's say that you have those two students and one's not as prepared for the next topic, can we predict which student is more likely to fail the class? So can we tell this green line from the two lines that maybe have some divergence but are still okay? And there's been some really nice work, I think more in the learning analytics space on this, both in the Purdue Signals project but also with Ming and Ming at University of Phoenix and a lot of other folks. And going on from there, which students are more likely to drop out of school or university? So it's a problem to fail, but if we lose the student entirely from their schooling, that's an even bigger problem. And you can think of dropout from high school, you can think of dropout from university, you can also think of just who's going to do well in high school but decide college is not for me. And there's been a lot of work the last few years to try to model these kind of things. So with educational data mining, we can predict the future. But is it enough to just predict the future? What if we predict the future and we don't do anything about it? I think the goal of predicting the future is to change the future, which sounds a lot like one of those science fiction novels I like to read. And there's a couple ways to change the future, I think. One is reports to students, instructors, and parents. The other is automated adaptation, and I'll give a couple of thoughts on both of those. So let's take a student who's got a misconception. And let's even say the software tells them, because there's a lot of learning systems that will recognize what are often called bugs in student thinking and say, wait a minute, you got this wrong, and here's why I think you got it wrong. And then the student has a choice to self-explain or not self-explain. And there's a lot of literature, some of it coming from EDM, like Ben Shee's best paper at EDM 2008, that shows that if students fail to self-explain, they don't learn. But if they do, they learn. And that's a well-known phenomenon in many areas, originally discovered in the early 90s by Mickey Chi and other folks. So the idea is that if we have a model in there that says, wait a minute, this student is not self-explaining, but if they did, it would really be beneficial, then we can do an intervention. And through that intervention, we can help those students learn even if they weren't going in that direction by their own kind of natural processes. Now that may take a lot of forms. Maybe we want an automated intervention to do that, or maybe we want a teacher intervention. Maybe we inform the teacher, this kid didn't self-explain this thing they need to. Can you do something about it? Let me give an example of automated intervention from our work on gaming a system, which, as I mentioned before, students game a system when they systematically guess, like 1, 2, 3, 4. Also, when they click through hints at high speed, like the system might have multiple levels of hints, and students just go hint, 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 until the system gives the final answer. Another example. There's a lot of different ways to game the system, and it's worth saying that just trying to eliminate it, for example, by putting in delays between hints, just seems to change what kind of gaming strategies students adopt. Now, it turns out from some discovery of models research that students who game the system start out below the rest of the class and fall further behind by post-test. So it's really a pretty strongly impacting on their learning. What we did is we built a automated agent, Scooter, graphics adapted from the Microsoft Office Assistant, but you'll see that we take Scooter to emotional places that maybe Microsoft Word doesn't. And Scooter, if the student is working properly, not gaming, he dances around and looks happy, and if he finds out the students are gaming, he gets less and less happy looking. That image on the right is what he does when you game him when he's giving you a supplementary exercise. And by the way, the middle school students we gave this to absolutely loved this. And the boys would sit together and get a happy Scooter and then try to see who could make Scooter catch fire the fastest. And that wasn't really what we wanted, but that's sometimes what happens with designs like this. So here's one of Scooter's automated interventions. When a student completely bypassed a problem by gaming a system, this Scooter would give them an automated intervention, an exercise, which covered the material they'd bypassed by gaming. Either how to give the answer or what place the current problem step had in the overall problem. And Scooter would keep giving it to you until you took it seriously. And I would say, by the way, in answer to your question, what are they learning when they work to set fire to Scooter? Yeah, that's not really a desired design thing, and I think that an ideal intervention would not have that happen. But I'll give some results in a minute that show whether Scooter was effective or not. So, first of all, adding Scooter to the system halves the number of students who are ever seen gaming. And if you look at the experimental condition, kids who got more of Scooter's exercises, so they gained more and Scooter intervened more, started out way behind the rest of the class, but caught up by post-test. By comparison, in a control condition where there wasn't a Scooter, and we just looked at how much harmful gaming there was, which is to say the conditions that triggered the detector, we see that again the students start out behind the rest of the class, but actually catch up, but fall further behind by the post-test. That confirmed previous results we've seen. So we can show an example here where by predicting the future that these kids are gaming and are therefore going to learn less, we can actually change it. So it's just one example, but it has that characteristic of predicting the future because we can tell these kids are gaming and they're likely to do much worse. But by knowing that, we can change it by throwing in interventions. And even though kids some kids like enjoyed making Scooter mad, it still seems to have worked on the whole. So, with educational data mining, and I think learning analytics as well, we have that possibility to predict the future so we can change it. We can try to take these links the student has, all the ways a student can drop off what's called the STEM pipeline, the pipeline to a successful career. And by the way, it's good to get people more interested in science and math. I'm happy too if people can succeed in other chosen careers. We need a world of people doing lots of great different things. But we need a world that our technology is helping to empower people to get where they need to be. So if we know a student's going to fail a course, if we can detect it early, maybe we can intervene before it's impossible to resolve. If we think the student is not going to be prepared for the next course, maybe we can figure out what this student needs and try to inform their teaching assistant or their instructor. If we think a student might actually succeed but not be prepared for their career, it's going to be a hard one to model, but I think we're going to get there, then we can try to empower them early. And I think motivational factors are an especially important one. There's a lot of research showing that differences in motivation as early as middle school and even late elementary can really make a big difference. And in some of our group's recent work, we've seen that models of students' emotion at the middle school level can actually predict whether a kid's going to go to college or not. So if we can tell that in middle school, maybe we can take that kid who's actually, for example, really good at math, but doesn't think a math career is for them, and target exactly that student to a summer program that'll kind of get them interested in math and make them feel like a math and science career is for them. There's lots of those programs out there, but typically they get the students who are already pretty excited. Maybe we can try to target exactly the students who would be most likely to benefit, so that everybody can have success in a career that's good for them and good for the world. So here you see, cutting off all these links by predicting the future and changing it. So again, with educational data mining, we predict the future, we change the future. So I'll open the floor to general questions and discussions in a minute, but first I want to quickly recommend some resources to everybody if you're interested in learning more about the EDM part of the greater learning analytics space. One resource, as I mentioned, is the Journal of Educational Data Mining. Open access for everybody, free for everybody, and as an associate editor, I would like to say we welcome submissions from members of the LAC community. Just like I think that it would be great for EDM folks to publish in SOLAR, I think it would be great for LAC folks to publish in JDM. Well, I welcome your submissions. Also, the Handbook of Educational Data Mining. It was published in 2010, so it's a little bit out of date because this field is moving so amazingly fast, but I still think it's really nice. I'm biased. Worth taking a look at. The Proceedings of the EDM Conference. If you're anywhere near Memphis this summer, I would encourage you to come see us for EDM 2013. Also, the submission deadline just passed, like this week, yesterday in fact. But there's still a poster category, so if you find yourself interested in coming, throw in a poster and come visit us. Just like the same as the LAC conference is in a couple months in Belgium, and I'm looking forward to being there and learning about all the great stuff going on since last year. A couple of articles you might be interested in. A review by me and Kalini Yosef and a review by me. These are both, again, a couple of years old. George and I have a review book chapter that will be coming out probably, I'm guessing, in about a year, and I hope that'll be kind of another great new resource. A couple other reviews that are really worth seeing. Cristobal Romero and Sebastian, oh great, glad to see that. Cristobal Romero and Sebastian Ventura at the University of Cordoba in Spain have written a couple other nice reviews. What's really nice about their reviews is where my reviews kind of just try to elicit a few key points and give a few key examples, they really try to be exhaustive and go through all the developments and list out all the really interesting papers. So I think that their reviews are definitely worth checking out as well to get an idea of the greater scope of the field. And I know that the SOLAR also has this new database on papers from LAC and EDM, which I would strongly encourage folks to check out. Some resources on data mining in general. I think, although they're again a couple of years out of date, I think that Andrew Moore's statistical data mining tutorials are really nice, and that's worth checking out. The field's moving really fast, and resources are changing all the time. Another resource, I don't remember if I put up a slide, but if you go to my webpage at Columbia Teachers College, just Google on Ryan Baker, and look at my teaching page, I have the course slides and the readings from all my recent courses up there. It might be of interest. But even better, maybe, on August 5th, 2013, we're going to have a MOOC on EDM methods called Big Data in Education, and it'll be available on the Coursera platform. The course is not yet on the web, but I would encourage you to email me if you want to be notified when the course is available for registration. And this MOOC is completely complementary to what you're taking now. This MOOC is going to be very focused on learning to apply the algorithms and methods in tools like RapidMiner and how to kludge those kind of tools for the kind of problems you see in education. And George, I am very happy for you to post my slides to the recordings page. That would be fantastic. So I hope to see several of you in the Coursera course. You know, come, tell your friends, tell everybody. The more the merrier. I don't know if I'm really going to get 30,000, but I'd be delighted to have it, and a little scared. So thank you all for your attention, and I'd like to open the floor for questions or comments. Thank you very much.
Thanks, Ryan, for that informative and clear walkthrough. Some of the work that you're doing in EDM and certainly where it's going. I just had to chuckle a little bit when you mentioned that your 2010 text is out of date. It really is reflective of the way things are moving in just analytics in education, educational data mining in general. Now, Juan is just asking how do we get the slides. I'm going to post them on the recordings link, and I'll throw that out shortly. So if I can just sort of direct a quick question at Ryan. So a lot of the work, you're looking at some of the EDM techniques and EDM software. To what degree does EDM and learning analytics fall around the K-12/higher education fault line?
That's a really good question, George. I think that to a large degree, I think learning analytics came out of a lot of people who started learning analytics were very interested in the higher education world, and a lot of the folks who started EDM in North America were very interested in the K-12 world, with an interesting leavening of folks interested in higher ed from Spain and the Netherlands. How exactly North Americans interested in K-12 got together with researchers in Spain and the Netherlands interested in higher ed, but didn't manage to bring in the North American folks interested in higher ed and the British folks in particular interested in higher ed, and how that caused a separate community would be a fascinating question for some sociologists of science later. I think these kind of things are really fun. But I think a lot of it, what I think caused the fault line to a greater degree maybe, was the difference in looking at problems in a more component-based, entitative fashion versus a more holistic fashion, and looking at issues of, people who came to EDM often came from the intelligent tutoring systems and user modeling and adaptive personalization communities, where the focus was really on automated adaptation, whereas learning analytics folks had the, I think, in some ways, much better, or at least just as good, focus of empowering instructors. I think there were a lot of little things like that that caused them to coalesce separately. And as with anything, these things are messy, boundaries are messy, and it's hard to kind of cleanly delineate, except that I think the two communities have developed distinct flavors, both of which are really valuable. Juan's question, and then Mark's. So folks have used EDM and learning analytics in places like med school. It was never published, but one of the analyses I did a couple years ago was studying gaming the system in medical residents. And it was scary how much gaming you saw. I've also been doing some stuff with military cadets lately. And to answer Mark's question, the EDM conference, I think, is a little bit of a smaller community than the Learning Analytics Conference. I think it's grown a little slower. We typically average about 150 people at our conferences. And the Society has a membership around, I think, 220 right now. Any questions?
Okay, if anybody else wants to grab the mic, please click the or raise your hand if you'd like, and I'll pass it over to you. Otherwise, questions and comments are welcome via text. Gail's just asking a question, but before I dive into that, one of the things would be nice if you could talk about a little bit, Ryan. This week in our course, we're looking at tools and techniques specifically, and you gave us a nice overview of the the 5-point techniques that you had in one of your earlier slides. So, but as a educational data miner, what kinds of tools are you using? What kinds of tools do your doctoral students use? Because in learning analytics, there is an interesting mix of tools. Some of them are the work that Shane Dawson and others have done around Snap, the social network analysis browser plugin, or a lot of, no, I shouldn't say a lot, but a good portion of the use in analytics still has an Excel focus. Some have sort of written a variety of different programs that they're using. It seems to be growing prominence. Probably the fastest growing tool that I've seen is R, which we have as one of our topics, one of our tools for tutorials this week. I've also seen a growing influence of SaaS tools, especially their enterprise level tools. IBM Cognos, and so it's really a smattering of informal instructor-based tools. Somebody that's written them, or it, just for their own computer scientists that's doing some interesting stuff, or the application of existing commercial tools for learning analytics. And now there's a growing group with InfoChimps and the Tableau and Datamir and others that are starting to get into this space as well. So that's the learning analytics slide. I'd like to hear what do you and your colleagues use in educational data mining?
That's a great list of tools right there, George. A couple of them are the same. I personally am quite a fan of Excel for feature engineering, and there's a lot of people who are big fans of R, although I don't use it myself. I think the most popular general purpose tool in EDM, I would say, is RapidMiner from RapidEye, which is a company in Germany, although there are free academic licenses. And aside from that, the Data Shop actually has a lot of tools that people like. And then there are kind of a smattering of researcher-developed tools. I mean, my group has a lot of tools we've developed, and if you go to my webpage, you'll find a few of them. We've developed our own code for Bayesian knowledge tracing that we make available. Joe Beck's group has a different implementation of Bayesian knowledge tracing that's also quite good. Judith Rodrigo's group has a tool called the EDM Workbench, which supports hand labeling of data examples. And there actually, I know of multiple submissions to the EDM conference this year that use that. There's a lot of tools, and a lot of people still kind of like to roll their own. Personally, I'm just a huge fan of RapidMiner. So let me answer. I saw some other questions kind of filtering through. Mark asked, aside from Signals by Purdue, does anything stand out as a live tool? There's a lot of stuff. There's a lot of widely available learning systems that have learning analytics or EDM of one sort or another built in. So the assessment system and the Inkits are a couple examples that have models based on EDM. For example, Inkits has models that detect student inquiry strategies and learning and disengaged behaviors to intervene with a little cartoon dinosaur. The assessment system uses assessments of student knowledge to recommend material for students to take, and also has little displays of student affect in the bottom left corner of the screen that are going to be deployed in a few weeks. Cognitive tutors by Carnegie Learning, which are used by, well, I guess like 600,000 kids a year in the U.S., have Bayesian knowledge tracing models of latent student knowledge built into them. And the examples go on and on. There's a lot of examples. Let me answer Gail's question. What makes for an interesting data set? Boy, that's a hard one. I think lots of data on things that matter. And the more things you can layer a data set with, the more models you can build, the cooler it gets. So it's nice to have data just on student performance. If you can layer that with a model of disengaged behavior or learning or affect, that makes it cooler. And if you get one of those, you can use that to help you build other ones. There's often a lot of pyramidness on models where you build one thing on top of another. And the cool thing about this kind of methods is that because if each model at each level is built on data mining, even if the earlier ones have errors in them, it actually corrects for that and can actually control for the errors to some degree, which is really nice. I think, of course, that having some indicator at the end of what really matters to you, whether it be dropout or final grade or standardized exam score, is also a really big bonus. Let's see what else we have here. The question, for those who would like to start a research, you consider the EDM or LAC and social networking sites to be very complex. Moodle, for example, would be more suitable source. I think you can do this with any kind of data. I mean, Moodle's a great source, and there's a lot of folks who've done learning analytics and EDM on Moodle. There's tools like, I know Stephen Edwards at Virginia Tech developed a tool to distill out data from Moodle courses. That's a great source. Educational software is a great source. I think that like a standard social networking site like Facebook does seem like it'd be pretty hard to get learning out of to start, but I think it'd be useful for lots of other kinds of analyses. One of the things I think we're seeing over the years is that, boy, you can do data mining, just an educational data mining and learning analytics with just about any kind of data if it's rich. So if you've got a good representation of what's going on behaviorally, if a student is just entering an answer to a math problem every 40 minutes, that's going to be really hard to do much analytics on. But if you've got steady behaviors over time and you can get information on things as they're happening, then you can do a lot. Other questions or comments?
Yeah, great stuff, Ryan. And certainly the development of tools that'll be interesting to see going forward is going to be how they become more broadly accessible. Certainly a trend I've noticed even over the last 4 years, 5 years, that tools that previously required a fair degree of technical expertise all of a sudden are now being made available with very easy interfaces for end users. And not everybody's going to be an EDM researcher or a learning analytics researcher. And that's why, especially just for a starting point, sometimes an interesting site to dive into is going to IBM's Many Eyes, just so you can get a sense of fairly simple level analytics. It's not overwhelmingly complex, but it does allow you to manipulate and play with data. Another one, Gapminder. I just tagged this to our DIGO group this last week. Download Gapminder and start playing with world health or economic data. And what these tools really allow you to do is to, not everybody's going to be, let's say, Ryan Baker, who's going to be, cutting edge, creating new algorithms and moving the field forward. Many folks are going to use analytics and data mining at a much smaller, or not small might not be the right word, but at a less research level and more focused on applications. So do you want to talk at all, are you seeing any trends in the way tools are emerging in EDM? Is there a transition more toward easier to use interfaces for end users, especially considering your HCI background?
Great question, George. I have to say that actually I don't think the interfaces are getting better. I think people are getting more aware of how to use them, and there's becoming greater knowledge. Between the 48 of us and the thousands of people no doubt watching this later, I actually think that RapidMiner 5.3 has a worse UI than 4.6 did. And I think that the tools are getting better, but they're not always getting easier to use. That said, I agree completely with what you said, George, about you don't need to be a programmer or a developer of algorithms to do data mining and learning analytics. Our group does innovate in those things, but in fact, the majority of the grad students, postdocs, and other folks in my lab actually don't program. My lab mostly uses existing tools in creative ways, and we have a couple of folks in the lab who can program, and they kind of help everybody else with getting stuff that does need custom coding. But these days, you can do a lot with off-the-shelf tools if you know how to use them right. It's really pretty impressive what you can do. So I think that as general tools get better, and I think, George, you named a great set of those, and RapidMiner is another great general tool. As those get better, I think it's going to be less and less necessary to know how to program and know how to innovate in your algorithms to do great learning analytics in EDM. But what is going to be necessary is knowing how to use the stuff right and not misusing stuff. If I could quickly give one example of that. One thing we've really pushed on in the EDM community is appropriate cross-validation. So cross-validation is when you build your model on one part of the data and test on another part, and you do that systematically across your data. And it's really important, in my opinion, for most educational applications that you have students, different students in your training and your test folds. So you build the model on different students than you test it on. Because otherwise, you make a model that you've tested that'll work on new data from the same students, and who cares about doing well on new data from the same kids? You want to be able to have your model work for different students. And our group has been really thinking hard about things like demographic level cross-validation, like will our models work on urban kids if we've built them on suburban kids, and trying to look into that. So I think the conceptual understanding, knowing how to use the tools and knowing how to use them right and in a deep, thoughtful fashion is going to be the way of the future in both EDM and LAC.
Great, and I would absolutely agree. And one of the assignments in this particular course that we did this year was we asked participants to start by creating, thinking about a particular challenge or situation that they would like to better understand and that they know they need to work with data to understand. So rather than targeting tools first or even targeting a particular technique, the intent was to have individuals think in terms of, you know, what is it that we're hoping to better understand? And then once that's been articulated and potential data sources identified, you know, at that point you can start looking for potential tools and other aspects, much like, you know, taking any kind of a, you know, qualitative or quantitative research program, you know, at a master's level, where the time needs to be spent first in understanding the logic of what you're trying to do, rather than taking a tool and just dropping it on it. Okay, Steve has a question in here. I'll let you read it and respond.
It's a great question. So first let me just say, in one comment on what George said, then that's just that I agree. I think you see a lot of bad work when people say, boy, I love algorithm X. What can I use algorithm X for? And a lot better work when people think about what they need. So great point, George. In response to Steve's question, you know, I'm not exactly sure where a database starts and where a database stops and where a data warehouse starts. I would say that in academia, except for the Pittsburgh Science Learning Center data shop, and maybe things like the National Student Clearinghouse, which has data for the United States on who goes to college and where they go to college, most of the time you don't see as much data warehousing being used in published EDM. But interestingly, I do some consulting for companies. In those situations, it's almost exclusively data warehouses. So I think that in some level, it's just how much data do you have, where's it coming from, and what are you trying to do with it? And I think that I suspect we'll see more movement to data warehouses, but I think we'll be seeing, you know, this is one of these just how much changes in a few years. Even if you have a small data set, like say 70,000 student actions in a learning system, that's enough to really do some good data analyses. And you don't need a data warehouse for that. And I laugh when I say that because, you know, 70,000. A decade ago, I remember giving a paper where I talked about a data set with 70,000 data points, and heard these oohs and ahs through the room. And nowadays, that's utterly unimpressive. So.
Great. Well, any comments from or any other questions? We're getting close to wrapping up, and it's certainly been a great chat and a great presentation by Ryan. So we've got a few minutes for additional questions. One I'm going to ask before you dive into the question that Lim Kin is asking is, what do you see when you work with students and when you work with data mining techniques and tools? What do you see common errors that new folks to data mining make or students make?
Interesting question, George. I'm going to throw the two most common errors I see. Three. The three most common errors I see. One is, like I mentioned before, not cross-validating at the appropriate level. And that one is a really serious one that you see fairly often, but not as much as you used to. The second one is a fondness for overly complex algorithms. Educational data has a lot of noise and a lot of bias, in terms of variables that we're not used to thinking about controlling and can't easily control for. So I often see that people want to use the fanciest algorithm out there. You know, they want to use a neural net because neural nets are awesome, or a support vector machine. And oftentimes, simpler algorithms, more conservative algorithms like linear regression or step regression, not stepwise, step, or for example, J48 C4.5 decision trees, or K-star or JRP decision rules, relative algorithms that that leave signal on the table but are a little better at avoiding noise, those algorithms tend to do a little better. The first time like a data mining person moves into EDM, you always see these papers with these really baroque algorithms, and they don't actually do as well. So that'd be one mistake. And I guess one third thing is ignoring what's already known. So clustering is a wonderful method. And domain structure discovery, where you just assume nothing to begin with, is a wonderful method if you know nothing. But if you know some things, you should think about using a blended or semi-supervised or even a fully supervised approach, prediction modeling kind of thing. Because if you already know something, why spend a lot of time using an approach that'll get you what you already knew? Now let me answer Lim's question. Does EDM deal with qualitative data like student feedback comments? Well, if you've got enough qualitative data, it becomes quantitative. That's one of the funny things about this kind of work. I mean, a lot of my work has been taking field observation methods, which is traditionally a qualitative kind of thing, and using them at trying to get enough of scale at them that we can actually build data mine models and treat it quantitatively. And what I would say is that student feedback comments, if you've got thousands of them, do text mining. It's no longer qualitative. Strictly qualitative analysis is not really an EDM thing. I mean, I think EDM is inherently a quantitative method, but I'm not persuaded that there are all that many things that truly have to be pure qualitative if you have enough. Or, in the famous words of Joseph Stalin, quantity has its own quality.
Well, you can't really end on a much more dramatic note than a Stalin quote, can you? One of the aspects, then, just to sort of conclude or move a bit to wrapping up, that's worth thinking about as well, is that we are, in many ways, not quite at the level where we want to be, tools, techniques, and otherwise within learning analytics, and I suspect EDM is very much in a similar space as well. One of the biggest challenges I imagine that both groups face is broadening the scope of the data that's being collected. When your data consists primarily of learning management system data or interactions of students within a particular piece of software, you're getting a slice of learning, but there's obviously, learning is a fairly complex social process, and as a result, you really want to look at broadening the scope of the data that you're capturing. I'm interested to see how the quantified self movement ties into this. Google Glasses, I think, is going to be another potentially interesting tool, even though I suspect eventually you'll be walking around with one of those and you'll get punched in the nose because folks are getting tired of being taped or whatever else is happening. Nonetheless, I think it's interesting to see how the field is developing, and I think for all of us here, it's been a pleasure having you, Ryan, give us an overview of educational data mining and areas in which your field is developing as well. So thanks again for a terrific talk.
Very kind of you to say that, George. It's always my pleasure, and it was my pleasure to virtually meet all of you. And if any of you have any further questions, shoot me an email. Google Ryan Baker. It actually works. And I look forward to talking more. Thank you again, George. Really a lot of fun.